Good evening. Today's quote is defeat is not the worst of failures. Defeat is not the worst of failures. Not to have tried is the true failure. Today's word is gourmet. A person who enjoys food and knows a lot about it. Dean returned to his gourmet preparations. Now this is fifth one. Just listen to me, but please do write the solution after the lecture. Let z be the given complex number 1 plus 2i upon 1 minus 3i. Multiply numerator and denominator by 1 plus 3i. So on simplification, I'm directly reading this. Z comes out to be what? Minus half plus half I. Now this is of the form a plus ib. We generally write x plus iy. Here a is minus half, b is half. So r comes out to be 1 by root 2. We have done similar sum. What is cos theta? Minus 1 by root 2. What is sin theta? 1 by root 2. Now at present, uh, you may not understand exactly why this angle, but I can tell you the logic. See, the point which represents the complex number is minus half half. The point minus half half lies in which quadrant? It lies in second quadrant, and therefore angle is greater than 90 degree and less than 180 degree. Also note that if you just consider cos theta as 1 by root 2, sin theta as 1 by root 2, they are trigonometric ratios for 45 degrees, and therefore answer is not 45, it is 90 plus 45. That is what? 3 pi upon 4 in radian. Now do not read this because you will not understand, as we haven't done trigonometry yet. So what is the polar form? Z equal to R cos theta plus I sin theta. Substitute. What is the exponential form? It is Z equal to R into e raised to I theta. So finally, it is 1 upon root 2 e raised to 3 pi upon 4 I. Sum number 6, let z be 1 plus 7i upon square of 2 minus I. Now the main job is to write this complex number in the form a plus ib. Simplify denominator first, you get 3 minus 4i. To divide by 3 minus 4i means to multiply by 3 plus 4i. So on simplification, note that I square is minus 1. So you get simple complex number. Z comes out to be minus 1 plus I. We represent it by x plus iy. Okay. Now, what is R? Modulus of complex number mod z. It is root of 1 plus 1, that is root 2. What is sine theta? Sine theta is nothing but y upon r. Y upon r means 1 upon root 2. Then cos theta is x upon r, that is minus 1 upon root 2. Same thing. In the previous sum also we got the same trigonometric ratios. So just write theta equal to 135 degree. That is how many? 3 pi upon 4 radian. See why 135 degree you will understand once we learn trigonometry, but at least you can appreciate this. The point representing the complex number lies in second quadrant. So the angle is greater than 90 degrees but less than 180 degrees. Okay, that is why 135. So what is polar form? It is z equal to r cos theta plus I sin theta. So that it is root 2 cos 3 pi by 4 plus I sin 3 pi by 4. Yes. And what is the exponential form? Please do not take screenshot. You have to write this. So it is root 2 e raised to 3 pi upon 4 I. In question 4, we were given complex numbers and we were asked to express them in polar form. Now the complex numbers are given in polar form in question number 5 and we are asked to express them in which form? X plus iy. The first one, in fact there are 6 sums, so first 3 we will discuss in this fashion. First one, root 3 into cos pi by 6 plus I sin pi by 6. What is pi by 6? 30 degree. Cos 30 degree root 3 by 2 sin 30 degree half. Open the bracket to get 3 upon 2 plus root 3 upon 2 I. That's it. So this is the complex number in the form a plus ib or x plus iy. Now at present just remember that what is cos 7 pi by 4? It is same as cos pi by 4, that is 1 by root 2, and sin 7 pi by 4 is minus 1 by root 2. I repeat, at present you will not understand this because we haven't done trigonometry. There is one part which is called as allied angles that we will be discussing in the next month. So just say yes to this. Cos 7 pi by 4 is 1 by root 2. Sin 7 pi by 4 is minus 1 by root 2. Substitute the values. So answer is 1 minus I. Third one, cos of minus 5 pi by 6 is minus root 3 by 2. Sin of minus 5 pi by 6 minus 5 pi by 6 is minus half. So this complex number takes the form 7 into minus root 3 by 2 plus I into minus half. That is, that is, minus 7 root 3 by 2 minus 7 I upon 2, which is of the form x plus iy. Now fourth one, we are given complex number in exponential form. So r e raised to I theta is given to be e raised to pi upon 3i. So clearly it is 1 into, so r is 1, theta is pi by 3. So what is z? Polar form, r cos theta, r into cos theta plus I sin theta. Substitute the values. Basically pi by 3 means 60 degrees. You have done this. Cos 60 degrees half, sin 60 degrees root 3 by 2. So half plus root 3 upon 2i, which is of the form x plus iy. So this is sum number 4. Now sum number 5. Now this you have to write whatever is written on the slate, because again you will understand this once trigonometry is done. So z equal to e raised to minus 4 pi upon 3i equal to r e raised to I theta. Therefore r equal to 1 and theta is minus 4 pi upon 3. Basically, can you tell me what is minus 4 pi upon 3? Yes, it is minus 240 degrees. See, angle measured in clockwise sense is negative. So just write down cos theta. We need cos theta is cos of minus 4 pi upon 3. Okay. Basically, cos of minus theta is cos theta. I think you have done this part in 10th standard. If not, we will be doing in 11th standard only. Now, can I write angle 4 pi by 3 as pi plus pi by 3. Just check. Yes, LCM is 3. 3 pi plus pi, 4 pi. Now, what is the advantage of this? Uh, we will be discussing this, that cos of pi plus theta is minus cos theta. So it is minus cos pi by 3. And I'm sure you know that cos pi by 3 is half. So this comes out to be minus half. Okay, right? Then sine theta, same lines, sine of minus 4 pi upon 3. You should know that sine of minus theta is minus sine theta. So minus sine 4 pi upon 3. That is minus sine of, same logic, pi plus pi by 3. Now, sine of pi plus theta is also minus sine theta. So minus of minus sine pi by 3. What is sine 60 degrees? Root 3 by 2. Minus minus plus. So root 3 by 2. Therefore, Z is nothing but R, polar form, cos theta plus I sin theta. That is 1 into what is cos theta? Minus half plus root 3 upon 2 I. Now 1 into means it is just minus half plus root 3 upon 2 I, which is of the form x plus iy. Right now, I'll explain sum number 5. Actually, sum number 5 is 1 minute. Yes. So compare to get theta as minus 4 pi by 3. Okay. Now you have to assume this. I'm telling you one more time because we haven't done trigonometry, and I'm definitely going to take this part again once we complete trigonometry. So cos theta, that is cos minus 4 pi by 3, comes out to be minus half, because cos of 180 plus theta is minus cos theta, and so on. Sin theta, so sin minus 4 pi by 3, using allied angle formulae, you get it as root 3 by 2. So Z is R cos theta plus I sin theta. 1 minus half plus root 3 by 2I. So minus half plus root 3 upon 2I. Sum number 6. Z is e raised to 5 pi upon 6I. Compare it with R e raised to I theta. So R is 1. Theta is 5 pi by 6. So cos theta is cos 5 pi by 6. Now 5 pi by 6 can be written as pi minus pi by 6. We will be doing this in the topic trigonometry. Cos of pi minus theta is minus cos theta. Now it is cos 30 degree, root 3 by 2. So it is minus root 3 by 2. Sin theta, same logic, sin of 180 minus theta, that is pi minus theta, is sin theta. Because in second quadrant, sine ratio is positive. Sin pi by 6, that is half. So use polar form. What is the answer? Minus root 3 by 2 plus half I. Now sum number 6, find the modulus and argument of the complex number 1 plus 2i upon 1 minus 3i. This for homework, because after simplification you get a complex number which is similar to, I don't exactly remember the sum number, but it is from question 4. Let me check. What was that? Minus half plus half I. Anyway. So on simplification, you get minus half plus half I. So R comes out to be 1 by root 2. Sin theta 1 by root 2, cos theta minus 1 by root 2. So theta, basically point representing the complex number, lies in which quadrant? X coordinate is negative. y coordinate is positive. So second quadrant, use common sense. Angle is greater than 90 degree but less than 180 degree, and ratios are similar to those for 45 degrees. So 90 plus 45, that is 135 degrees. In radian, 3 pi upon 4. Actually, this is not asked. Polar form is not asked. Okay. So just you have to write that modulus is 1 by root 2 and an argument is 3 pi upon 4. Sum number 7. Convert the complex number I minus 1 upon cos pi by 3 plus I sin pi by 3 in the polar form. Now what is cos 60 degrees? Half. What is sin 60 degrees? Root 3 by 2. Now multiply numerator and denominator by 2 to get this. Now to divide one complex number by other means to multiply both numerator and denominator by complex conjugate of denominator, which is 1 minus root 3i. Simplify, open all the brackets, replace I square by minus 1. Okay, you get this. 2i plus 2 root 3 minus 2 plus 2 root 3i upon 3 plus 1, 4. You can divide numerator and denominator by 2. Again, you have to write complex number in which form? A plus ib. See. So what is z? Minus 1 plus root 3 upon 2. This is real part. Plus, what is imaginary part? 1 plus root 3 upon 2. So this is of the form a plus ib. These are the values of a and b. What is r? Root a square plus b square. You have to be very careful. See, these are the basics I usually talk about. You should be able to square this. Then you should be able to add fractions. So on simplification, you get r as root 2. Right? Now, what is cos theta? Root 3 minus 1 upon 2 root 2. Do we know the angle whose cosine ratio is this? No, we don't. So cos theta is this. This is sin theta. At the most, we can write tan theta from this to get root 3 plus 1 upon root 3 minus 1. And then we say that the polar form is z equal to r into cos theta plus I sin theta. Just put the value of r. Let theta be as it is because it is not one particular angle. So it is root 2 cos theta plus I sin theta. And of course, you have to mention where tan theta is root 3 plus 1 upon root 3 minus 1. It can be seen that this is positive because root 3 minus 1 is positive. So is root 3 plus 1. Okay. Actually, the point representing the complex number is what? Root 3 minus 1 upon 2. So x coordinate is positive, y coordinate is positive. So the point is in first quadrant, and that is why the terminal arm lies in first quadrant. So theta is greater than 0 degree but less than 90 degrees. Sum number 8. For z equal to 2 plus 3i, verify the following. Actually, these are the properties of conjugate. First one is conjugate of conjugate is original complex number. Z is 2 plus 3i. What is z bar? To get the complex conjugate, change the sign of imaginary part. So it is 2 minus 3i. Now it is conjugate of 2 minus 3i. Change the sign of imaginary part. So 2 plus 3i. But it is z. Hence the result. Second, z into z bar 2 plus 3i. Write down. Into 2 minus 3i. 4 minus 9i square. So 4 plus 9. Why? Because I square is minus 1. See, every time you have to write this. That I square is minus 1. That is why it is 13. Okay. Now it is mod z. It is root of 2 square, that is 4. 3 square 9. So root 13. So it is square of modulus z. It is 13. Therefore, z into z bar is nothing but mod z square. Third one, we are asked to show that z plus z bar is real. We are getting 4, which is purely real. But in fourth, they are not saying z minus z bar is purely imaginary. They have asked us to prove that z minus z bar is 6i. So just substitute the values. Yes, we are getting 6i. Note that if I take z as say 11, is 11 a complex number? Yes, it is. What is the conjugate of 11? 11. What is the difference? 0. Is 0 purely imaginary? No. So don't say that z minus z bar is purely imaginary. Okay. Now we'll be solving sum number 9. Actually, first two you can do for homework. First and second for homework. Third and fourth we'll solve here. Third one is Z1 Z2 bar is Z1 bar into Z2 bar. Okay. What is Z1? It is 1 plus I. It is given. And what is Z2? 2 minus 3I. So Z1 into Z2, 1 plus I into 2 minus 3I. Just open the brackets. So it is 2 minus 3I plus 2I minus 3I square. So this is 2 minus I plus 3. You have to mention the reason for that. So 5 minus I. Is it? Z1, Z2? Yes. Now, its conjugate. Therefore, Z1, Z2 bar is 5 plus I. Number 1. Now, I will find the product Z1 bar into Z2 bar. Z1 bar into Z2 bar is nothing but 1 plus I bar into 2 minus 3I bar. Now what is the conjugate of 1 plus I? 1 minus I. And that of 2 minus 3I? 2 plus 3I. So it is 2 plus 3I minus 2I minus 3I square. So 2 plus I plus 3. Therefore, I am getting Z1 bar dot Z2 bar equal to 5 plus I. This is number 2. So from 1 and 2, see, presentation is important. From 1 and 2, I can say Z1, Z2 bar is Z1 bar into Z2 bar. That is conjugate of product. How will you explain this in words? Conjugate of product is what? Product of conjugates. Right on? Now fourth one, first we have to find Z1 by Z2. Tell me what is Z1 by Z2? So it is 2 plus 3i plus 2i plus 3i square divided by 4 minus 9i square. Check this. So 2 minus 3 minus 1, I'm getting minus 1 upon 13 plus 5 upon 13i. Okay, this is Z1 upon Z2. But we are asked to find its, not modulus, its conjugate. Okay. So Z1 upon Z2, I'll put this in bracket, bar, that is complex conjugate, is minus 1 upon 13. You have to change the sign of imaginary part. Okay. So this is number 1. I'm getting that as minus 1 by 13 minus 5 by 13i. Now we will be finding Z1 bar upon Z2 bar. We must get the same. So Z1 bar upon Z2 bar equal to. Now what is conjugate of 1 plus I? I'll write this directly. 1 minus I, okay, upon, what about denominator? 2 plus 3i. Just open the brackets. Just a minute. I'll write this part once again. So Z1 bar upon Z2 bar is minus 1 upon, because 2 minus 3 is minus 1, right? So minus 1 upon 13 minus 5 upon 13i. This is number 2 from 1 and 2. See, presentation is important because this sum is asked for 3 marks. Jitna dam utna kam. So you have to write it properly. So how will you describe this in words? Conjugate of quotient is conjugate of numerator upon conjugate of denominator. Now, there is one interesting theorem given by De Moivre's. We are going to prove this using method of induction. Now, don't ask me because at present you will not understand this. We are going to discuss this method in second semester. So what is that theorem? Cos theta plus I sin theta raised to n is cos n theta plus I sin n theta. This is very interesting. Initially or in second semester, we are going to prove this result for only natural values, but it is seen to be true for rational numbers also. Okay. Now, this part is important. If two complex numbers z1 equal to r1 e raised to I theta 1 and z2 r2 e raised to I theta 2 are multiplied, their moduli are multiplied. See how to find z1 z2. It is r1 r2, but r1 is modulus of z1. I hope you remember this exponential form. R2 is modulus of Z2. So their moduli are multiplied and arguments are added. as per laws of indices are to be added. So their product is R1 R2 e raised to I theta 1 plus I theta 2. Take I common to get theta 1 plus theta 2. So the conclusion is when two complex numbers are multiplied, their moduli are multiplied and arguments get added. Similarly, if we divide one complex number by other, their moduli are divided and arguments get subtracted. Reason, laws of indices. A raised to m upon a raised to n is a raised to m minus n. Okay. Now this comes Moivre's theorem, De Moivre's theorem. Cos theta plus I sin theta raised to n is cos n theta plus I sin n theta. At present, we have to accept this without proof. Okay. So that's it for today.